In this video, we are going to go over the concept of specific heat, which is the last material that you guys are responsible for in chapter 3. Let's get started. Specific heat is the amount of heat that raises the temperature of exactly 1 gram of a substance by 1 degree Celsius. Even though there are some courses in which you're tested utilizing this equation, understand that in this class, you are responsible for understanding application of the concept of specific heat. Specific heat has units of joules per grams per degree Celsius in the SI system, or calories per grams per degree Celsius in the metric system. As you can see, we have the equations for specific heat in the red box. But again, when it comes to specific heat, for me, it's more important that you guys are able to understand the concept of specific heat and will be applied in a situation. So let's take, for example, here on the left side of the slide, we have the image of a radiator, okay? So from experience or from common knowledge, you know that a radiator is used to cool off the engine in a car. The reason why that happens is because the engine of a car undergoes a series of combustion reactions, okay, from the gasoline if it is a gasoline-driven car. And that heat that is generated from the combustion reaction, and we previously in other videos explored already combustion reactions. When this heat is released, then you need a method that in the context of your car, that heat that is released is absorbed and then is released into the environment a little bit slowly. So the reason why I bring that is because in certain countries, instead of using coolants with water, sometimes they can put in radiators just water. Why is that? Well, if you compare water's specific heat to other substances, understand that water has a high specific heat. Okay? So because water has a high specific heat, based on the definition, that means that there's a, and then the definition is here. Having a high specific heat means that there's a greater amount of energy that is required to raise the temperature of 1 gram of substance by 1 degree Celsius. So if you're going to put something in your radiator, you would prefer things that have a higher specific heat. Okay, in this example, water will work. Let's look at 2 more examples of applications for specific heat or specific heat capacity. Okay, here we have 3 different pots. Now, from a personal experience, I grew up in a household in which there were pots specifically for boiling water, some for cooking rice, some for cooking stews. And at times, I honestly thought that my grandmother was overreacting over this, but there was a method to her madness. This is the reason. When you have pots and pans of different materials, the amount of heat that needs to be placed in that specific pot or pan will allow your food to be cooked at different ways. Okay, if you want something to be cooked faster, then you will choose things that are lower specific heat. If you want things to heat up in a more slower, then you are going to heat pots that are going to have a higher specific heat. So here I have an example in which we have a pot made out of copper, one made out of iron, and one made out of aluminum. in the table above, we have the specific heat for these three substances, okay, in terms of joules per kilogram per Kelvin. Now, what you can notice here is that if we compare the different specific heats, understand that looking at the value, the copper has the lowest specific heat, okay? Iron has a medium specific heat, and then aluminum has a high specific heat. And again, those descriptions I'm just using because of comparison to each other. Not because those values are specifically large, medium, and small. Okay, this is just from comparison to one another. So again, the trend in specific heat is that a substance with high specific heat will require a high amount of heat to raise the temperature of 1 gram of substance by 1 degree Celsius. Okay, so what does this mean? Let's say that, for example, we consider that each one of these pots have 100 grams of water. Then, each of them, let's assume that they have the same mass. So each one of these pots have the same mass. Let's say that we apply heat, the same amount, to each of them. Then, I will propose a question to you guys. Which pot will boil water faster? Okay? And the answer to that would be the copper. Why? Because it has the lowest specific heat. So what does this mean? That if you apply the same amount of energy to these three, because copper has the lowest specific heat, it will get hottest the fastest, meaning that that energy will go from the pot to the water and it will boil then fastest out of the three. Okay? So, in part E of the worksheet, as you can see, we also have another application for specific heat. This is more related to us that live in Southern California. And as you can see, the question reads, using the concept of specific heat, explain why ocean water is cooler than sand at the beach on a hot summer day. Well, if we rationalize it, this means that here we have the sun. And the sun is the one that is going to be producing the heat. Okay, so this is going to be the source of heat that is going to be applied to the sand or the water. Let me just color them both. So this is going to be my water. And let me just get a color for the sand. I'm not going to color the palm tree, but this is our sand. Okay? So, if you have gone to the beach on a hot summer day, you know that the sand is hotter than the water. Why is that? The sand has a lower a specific heat. When compared to the ocean water. Since the sand will have a lower specific heat, when the sun radiates and produces heat, understand that having a lower specific heat means that you will get heated faster, and that's why the sand will feel hotter compared to ocean water. So ocean water will have a higher specific heat compared to the sand.